since I can actually just type this. Be a lot easier. So 10.2 mass in mole. So we're looking at how atoms don't weigh the same amount. Atoms are different sizes. So if you were to have a mole of carbon atoms, they would weigh very differently than a mole of, say, gold atoms. It's a similar thing. You think about, you have a dozen eggs. Well, an egg's mass, a large egg, has a mass of about 60 grams. Compare that to a bowling ball, where its mass would be about 5,000 grams. So you can think of atoms in a similar way. Now, they differ a lot in size and in mass, just like an egg and a bowling ball differ a lot in size and mass. So if you were to have a dozen eggs, that would weigh a very different amount than a dozen bowling balls. And it's analogous to saying you have, say, helium atoms versus gold atoms. Gold would be much bigger in size than helium, just like a bowling ball is a lot bigger in size than an egg. So we're talking about atoms. We're thinking about two different things. Thinking about the size of the atoms, their mass, as well as how many atoms there are. So if you had 1 mole, oh, sorry, I'm gonna go back to this for a second. 1 mole of gold. Go to the periodic table and look up gold. And what you would see at the bottom is 196.96. That tells you the mass of 1 mole of gold. 196.96 grams is equal to 1 mole of gold. If you look up, say, oxygen on the periodic table, you see it's element 8. So the top number, remember, that tells you how many protons and electrons there are in gold, or in this case, oxygen. So there's 8 electrons, 8 protons in oxygen. The number that's below that would be the mass of 1 atom of oxygen in AMU. So it's 15.99. But this also tells you the mass of 1 mole of gold. So it's 15.99 AMU for the mass of 1 oxygen atom. But it's also 15.99 grams for 1 mole of oxygen. So this number has 2 different units. They tell you 2 different things. So it tells you both the mass of 1 atom in AMU, but also tells you the mass you need to get 1 mole of a certain element. So today what we need to do is look at the periodic table and look at the bottom number for these elements, and that bottom number tells you how many grams you need to get 1 mole of a substance. So if we have 3 moles of carbon, they're going to ask you, what is the mass of 3 moles of carbon? So what you do is go to the periodic table, look up carbon, And so we'll see a 6 on top. That tells you it has 6 protons, 6 electrons. On the bottom, you're going to see 12.01. So that bottom number tells you that there are 12.01 grams for every 1 mole of carbon. So that's our unit multiplier. So we take the moles of carbon that we were given, 3 moles, and multiply it by 12.01 grams, we were given that from here, over 1 mole. So we want the moles to cancel out, so we have to have grams in the numerator. The moles will cancel out. We do 3 times 12.01. That gives us 36.03 grams and 1 mole of carbon, or 3 moles of carbon. So that's our conversion between moles and grams. Whatever amount of moles we have, we multiply it by the number that we see below the element. This is called the molar mass. This tells us how many grams you need to get 1 mole of a substance. So when you have 12 grams of carbon, that means you have 1 mole of carbon, which means that you have 6.02 times 10 to the 23rd atoms in that sample. So this tells you the weight you need to get this many atoms in a sample. And that will differ for every element. Every element has different molar mass because every element has different size atoms. Let's do one more example with this. But before I go on, are there any questions about what I covered? Okay. All right, so let's say we have, actually, sorry, I did the same thing I did last time. Let's say we have this. We have 500, yeah, it's still doing that. Sorry, bear with me here. My pen keeps on being pushed down, doesn't get up. Okay, so we have 525 grams of calcium. And they're going to ask us to go from grams to moles. So the other example I showed you, we went from moles to grams, and this time we're going to go from grams to moles. So it's just the reverse of what I showed you. So we need to go on the periodic table, look up calcium, and what we'll see below calcium is 40.08. Now your periodic table might have more decimal points. It depends on the kind you have. So some have 2, some have 5 decimal points. It really doesn't make a difference at this point. Just use whatever you've been given. So if yours has 2, which really I think is, you don't need any more than 2, you just keep it at 2. But just use whatever you've been given on here, but it will vary a little bit from table to table. So use this number right here, and that says that there's 40.08 grams in 1 mole of calcium. And we have 525 grams of calcium. We want to convert that into moles. So 525 grams of calcium. We'll use the unit multiplier, but it's going to be the reverse we did before. So we want to cancel out grams. So we need grams in the denominator. So we're going to take this, put it in the denominator. So the grams will cancel out. 1 mole in the numerator. So we divide by the molar mass if we have grams and we want to go to moles. We multiply by the molar mass if we have moles we want to get to grams. So we do 525 divided by 40.08, and that gives us 13.1 moles. And again, the abbreviation for mole, we just do MOL. We leave off the E at the end. So that today is the new material in section 10.2. Do you have any questions about what I went through before we go on? Okay, so I'll have you work on some homework on page 328 and 329. Do 15 through 18. And just go ahead and work on that. Any questions you can ask me. But it's 15 through 18, pages 328 and 329.